Graph, one of the most powerful tools that we ever created. People use graph to do vast variety of things, and you can see the graph all around the world. But did you know that the computer program can read the graph and do useful things with it? Not like just creating the graph, but people make programs to organize trip schedules, calculating shortest path from A to B, even sort the relationship between things. Today we will not go into that much of details. We will just explore two different topics: breadth first search, or BFS, and depth first search, or DFS. I assume you know the basic knowledge of the graph in the computer science because I do not have time to explain that in this video. Check out the link in the description for the good video explaining of that. Alright, BFS and DFS, what do they mean? In general, BFS is to search all the nodes in the same layer first, before going any deeper. DFS is the opposite. The algorithm will dig into the rabbit hole until it hits the bedrock before it goes wide. And I know this might be a little bit too abstract, so let us see an example with BFS. So here is a FIFO array and a graph that have root A selected. Let us say we want to find H. Now A is the root. The BFS will start from here. So we put it into the stack. Now the program will go to every node under it, which is A's children's node. But for convenience reason, we just assume the program will check from left to right. So now we just go ahead and visit B, which do not check yet. So we will put this into the stack, and we will do this to C and D and E until every child node that A have were in the stack. Now every children of A were in the stack, and we're done doing operations with A, we will remove it from stack. And B will become our next node doing operation on. So we will repeat the steps that we have done to A and just put them into the stack. And after we finally empty the stack, we finished a worst case search in BFS. The demonstration that I just presented to you will give us a clear understanding of the time complexity of BFS. BFS will put every node into FIFO queue once. Therefore, we have O of V. Then we will go over every node's edges to check our new nodes under it. So we'll have O of E. After visiting every node and every edge, we finish our worst case BFS, which will have the time complexity of O of V plus E. BFS could be useful to find shortest distance from root to the desired node, by basically what we call distance property. This will record every node's distance from the root. Based on the algorithm, the distance will be its parent's node distance plus 1, where root is 0. If we follow the BFS, we can see each layer has the same distance. However, if we use DFS on it, which record the start time and finish time, we will have a very large hops to the opposite direction of the search algorithm. But since the BFS will make each layer the same distance, BFS hops will usually smaller than the DFS. Wait, what is DFS? DFS is an algorithm which will traversal a graph by going to the very left first. Once it reaches to the end, it will go back to its parent node and visit another node of its parent until it finishes all the nodes in the graph. DFS will check, in this case from left to right, the very left node. If it does have child node, it will put its very left node onto the stack and move the pointer to that node. It will repeat this process until there is no nodes under the pointer node. Then the pointer will go back to its parent node and put the second left node into the stack. After all nodes under the pointer nodes was visited, DFS will remove these nodes from the stack. Compared to the BFS, DFS was way better on some applications, such as finding the loop in the graph. Here we have a graph, and each node has a color property. When the nodes were not visited before, the color property of these nodes were white. Then we put them into the stack, we change its color to gray. And right before we remove it from the stack, we return its color to black. These three colors represent the status of the node. So when we traversal the graph using DFS, and we reach a node that is gray or black, we know that node was visited before. Therefore, we can identify the loop. And as the same reason with BFS, the worst case, in the worst case, the graph do not have any loops or one loop at the very end. DFS will put every node into the stack once. Therefore, we have OV. Then we will go to every node's edge to check for its child nodes. So we have OV. After visiting every node and every edge, we finish our worst case DFS, which will give us a time complexity O of V plus E. And that's about it. The DFS and the BFS are really useful and interesting algorithms that computers interact with the graphs. Hope you like it and thank you for your time. Peace.